Dear calculus students, in this video we are going to look at two free response questions which are for differential equation. So take a look at this example 11, which is a past AP exam question. You are given dy dx is equal to x times y over 2. Know that dy dx is a slope. So slope is defined that you multiply the two coordinates x and y and you divide by 2. So number one, A says on the axis provided, sketch the slope field for the given differential equation. So understand that here if x is a 0, slope will be 0. If y is 0, slope will be 0. So all these slopes are 0. So certain key points you should be able to do it faster, that all the slopes are 0. X and y both are 1, slope will be half. So which is a little bit not so slant, but like slightly horizontal line. 2 and 1 divided by, so this is a 45 degree. This will be a little bit steeper. Those are like a steeper slope. They are all going up. Now here you would see that x is negative, y is positive. So this slope will be negative slope. And this will be also negative slope, and that, so try your best to sketch the slope field based on multiply the two coordinates and check positive or negative. Usually sketching slope field is not more than 1 point on the AP exam, and the grade is based on the 0 slope, undefined, positive or negative. Now let's take a look at B. If f be the function that satisfies the given differential equation, write an equation of tangent line passing through 1 and 1. So first of all, let's write the equation, and then we have to use the equation of tangent line. So we already did this in way back in chapter 2 or chapter 3. Equation of tangent line is always y minus y1 m x minus x1. So my equation of tangent line for B will be y minus 1 m x minus 1. Sometimes students get confused. How do I find the slope? How do I find the slope? Well, don't forget the slope equation is already given to you, which was dy dx x times y over 2. So in this case, slope will be 1 times 1 divided by 2. So slope is 1/2. So this is your equation for B, equation of tangent line. Now use your tangent line equation to estimate the value of f of 1.2. So you have to, all you have to do is approximation, substitute 1.2 here. You do not simplify much. 1.2 minus 1 and you are adding 1. So this will be your answer. Don't bother to simplify, just leave like this. Do not simplify. I know you don't have to simplify, but I'm just showing you that the answer is 1.2 minus 1 is a 0.2 divided by 2. So this is 1.1. It's okay if you write equal to sign, or you can put squiggly line. So this is simple B, finding equation of tangent line and using it to evaluate 1.1. So done with B. Let's talk about C. Find the particular solutions of differential equation. Particular solution means we have to find a C using this initial value and use your solution to find f of 1.2. So this was our estimation. Now we are going to find the actual solution. I'm going to use the white space given here. So first thing is you need to know how to separate the variables. Multiply by dx. Now, how do you move this y on the other side? You have to separate the variables. That means you divide by y on both sides. So dy over y is x over 2 dx. Common practice is, if any coefficient is there, leave it on the x side, because eventually you have to solve for y. If I take the 2 on the other side, I'm increasing my work, because at the end I will have to divide by 2. So always leave the coefficient on the left side. Next is find the antiderivative. This separating the variable is the most important one. Separating the variable is the most important one. Now, once you separate, you do the normal solving. So antiderivative of 1 over y. You need to review your anti-differentiation rules. 1 over y is ln y, absolute value. Now we don't have to write plus c here because c plus c is another c. Antiderivative of x over 2. I'm separating 1/2. Antiderivative of x is x square over 2 plus c. So let me make it clear. This is x square over 4. Let me rewrite this so that it looks a little bit better. My handwritings are not coming out clear. X square over 4 plus c. Okay, this is not a general solution yet. You still have to find c and you have to still solve for y. You have two options. You want to find a c first and then solve for y, or you want to solve for y first and then find a c. Either one will work. So you are given a point 1 and 1. So if I say ln 1 is equal to x square over, x is a 1, 1/4 plus c. Now we know that ln 1 is a 0, so we get c is equal to negative 1/4. Solve for c. Substitute, let me rewrite this. X is a 1. I'm using 1 and 1 to find the value of c. Now c is negative 1/4 because ln 1 is a 0 and this 1/4 goes on the other side. So I'm going to, I'm sorry, I'm not using the right thing, but I'm going to move it here. Ln y is equal to x square over 4 minus 1/4. You cannot stop here. You still have to solve for y. We know that solving for y means you raise it to the power e, and that means y is equal to e to the x square over 4 minus 1/4. This is the answer, part of the answer for B. No, I'm sorry, not B, but C. Let me move that. This is the particular solution. That's my answer for C. Now it says use your solution to find f of 1.2. So this is f of 1.2. I have to use my equations. So which is e to the 1.2 square divided by 4 minus 1/4. Stop here. Do not use calculator. You don't have a calculator. You just leave like this as long as all are numbers. This is your actual solution of 1.2 using your actual equation. So have clear idea. B is approximation using tangent line. C is finding actual equation. And then we use that equation to find 1.2. Now, as usual, anytime we find the answer, we have to compare. We have to compare the estimate and the actual answer and the estimate. Now, obviously, we did not simplify, so we don't know which one is bigger number or which one is a smaller number. And that's the reason they say use your slope field to explain. Use your slope field to explain. So let me show you if I try to sketch the graph using 1 and 1, if I have to use this point 1 and 1, you can clearly see my graph, my solution curve is concave up. And we should know that if the graph is concave up and we draw the tangent line is always below. This is all review from the previous units. I mean, not the previous, but the semester 1, we learned that. So how do you write? Compare your estimate found. Was your estimate found in part B underestimate or overestimate? Use your slope field, explain why. So I just type this answer to explain here. We can see from the slope field that solution curves are concave up. Tangent line is below the curve f of x. Therefore, estimation is underestimation. Always try to sketch the graph and tangent line that you can see that the tangent line is below. This is very important. The keywords here you have to use is concave up, tangent line is below, and underestimation. Those are the three words we are looking at when we are grading this question. So one more time, I'm going over this question here is asking for slope fields, sketching slope field, equation of tangent line, use the equation of tangent line to estimate. Since this is a differentiable or separable, so we can separate the variables and we solve it. Usually solving is a huge part of the grade. You have to separate the variables, correct antiderivative, use the initial value, find the C, find the equation, and then comparison. I hope this question has helped you. Now let's take a look at the second question, which is a little bit different and slightly complicated. This is 2007, and we have seen this type of question again and again, repeating. So let's have open mind and try to make sense of each of these separate ones. Consider differential equation. So this is my slope equation. dy dx is 1/2 x plus y minus 1. On the axis provided, sketch the slope field for given differential equation 9 points. So here x is a 0, so y is also 0, slope is -1. So I'm just trying to sketch the -1. This will be, slope will be 0, 1 minus, this is slope is a 1. I'm just estimating slope is 1.5, is a 1/2 slope this point. This is -1.5. This is also negative slope, and that's also negative slope. This will be x is 1, 1/2, 1 is 0, so that's also negative slope. Okay, so sketching slope field is not a big deal. I'm not going over much detail. You just read the coordinates and use this equation. Slope is 1/2 x plus y minus 1. Read the coordinates, add them, sketch this line. B is the most important part here. B is finding second derivative, which I'm going to explain because many students forgot how to find the second derivative. I'm going to use the white space here to do B. Pay extra attention for B. Find the second derivative. You are already given dy dx is 1/2 x plus y minus 1. Let's find the second derivative. Second derivative is, I'm trying to find d dx. Remember, second derivative is not derivative square. Second derivative is not derivative square. Okay, so this side I get d square y over dx square. Now how do we write? D square y over dx square. Now here, derivative of 1/2 x is 1/2. Variable matches, you get 1/2. Derivative of y is dy dx, not 1. Derivative of 1 is a 0, so I don't have to write. Okay, let's read the question again. Find the second derivative in terms of x and y. So I have dy dx, which means you have to do double substitution. What is dy dx? What is given to you as a dy dx, which is your original equation? 1/2 x plus y minus 1. You can simplify here. Second derivative is 1/2 x plus y. 1/2 minus 1 makes it -1/2. This is my second derivative. Okay, so it says find the second derivative in terms of x and y, which we already did. Describe regions in xy plane for which solution curves to the differential equation is concave up. You have to make a connection. Concave up means my second derivative has to be greater than 0. Second derivative, I cannot write f prime prime here because my derivative is multiple of x and y, so do not use f prime prime. My second derivative is greater than 0. So here we came up to here, my second derivative. Now I'm going to put it greater than 0. But then how does it help me to describe the solution curves? This part is tricky. How does it help me to describe the solution curves to be concave up? So here, all you have to do is solve for y. If I solve for y, negative 1/2 x plus 1/2. Everything goes on the other side. And all you have to say is if solution curve are above the line 1/2 x plus 1/2, this is my y equal to mx plus b. Above the line y is equal to negative 1/2 x plus 1/2, then they are concave up. Okay, let me explain one more time. We are given to describe the solution curve which would be concave up. They want to make us the connection that concave up means second derivative has to be greater than 0. So put this second derivative greater than 0, solve for y, and we can say the solution curves are above the line. Greater than means if the line is greater than this, they are concave up. So let me explain on what that means is if my line is somewhere here, think of this 1/2 negative roughly. So if my solution curves are above, they will be concave up. If my solution curves are below this line, you can see that there is no concavity. So if you see this graph, they would look like concave up. So this is my cutoff line, and that's all they want to see. If they are above, then CC up. Okay, so let's take a look at C. Let f of x be the particular solution to the differential equation with initial condition 0, 1. Notice you can never solve this equation. This equation is not separable. You can never separate, you can never solve. No matter how much mathematics you do, it would be illegal math to separate x and y's. So they say there is a solution. Pretend that there is a solution. Does f have a relative maximum or minimum or neither at 0, 1? Now we cannot use the slope field that this is concave up. We have to use calculus to find if it has a relative max or relative mean. So to answer C, you have two choices. Shall we use a first derivative sign chart and check if max mean, or we have to use a second derivative? So I'm just writing here, cannot use first derivative test and sign chart. Why? Cannot, because think about this, this is a f prime. You have only x value 1 is 0, but then you know that the what other numbers are going to be. You have no idea what's the y values. You are not given the whole y values. You cannot make a sign chart. So you have to use the second derivative test, which we already have a second derivative here. So to check, my point is given x is 0, y is 1. So let's check dy dx. Dy dx at 0, 1. If I substitute 1/2, 0 plus 1 minus 1 is 0. So I know that there is a critical number because my slope is derivative is 0. Now let's check the second derivative, d square y over dx square at 0, 1, which we have already here. We found the second derivative here, which is 1/2 0 plus 1 minus half, right? So you just have to see, is it going to be greater than 0 or less than 0? 0, 1 minus 1/2. 1 minus 1/2 is 1/2, which is greater than 0. So I'm going to write the solution answer for C here. How do you write the answer for C? Using second derivative test. F prime, no, should not use F prime. dy dx at 0, 1 is 0, and d square y over dx square is greater than 0, which means graph is concave up. You can make connection here, concave up, and there is a relative minimum at 0, 1. This will give you full 3 points. They want to see that you are making connection with the calculus part. You cannot use the slope field. You cannot use the previous example was asked using slope field. Here, you have to use the second derivative test. All you have is ready second derivative, substitute x equal to 0, y equal to 1, check the slope is 0, second derivative greater than 0, concave up, relative minimum. Okay, so let's talk about the last piece here on D. Find the values of m and b, the solution to the differential equation. So many students, this question has been asked 2-3 times in AP exam. I have seen that, and I was also struggling on this, that what they are trying to ask us, what is y equal to mx plus b is a solution to the differential equation? We did not make connection what they are trying. But then when I looked at the answer key and I found, oh my God, that is such a silly question. So what that silly question is, find the values of m and b for which y equal to mx plus b is a solution to the differential equation. So we already have that line here. Y is equal to negative 1/2 x plus 1/2, right? We draw the line here, this line, where the solution curves are like this is the boundary. All you have to compare that what's the value of b. What's the value of b is 1/2, and what's the value of m is negative half. That's it. M is negative half, b is 1/2. So make sure you watch this video again if you did not understand. The most important concept we have seen all the time being used is use of second derivative. This is, you are going to find this several locations, and making sure that you are using chain rule. Okay, don't forget to watch the second video, which I'm going to make for second examples. Thank you.